is mainly four practices. Rain gardens and bioretention areas, there's two different design of the same concept. Rainwater harvesting, green roof, and permeable pavement. There are variation on those, but they would all fall into one of those four categories. For example, there's something that they call tree pits, and that's basically creating space under sidewalks with a lot of soil to put trees in so that runoff goes in it. That's a form of a rain garden or bioretention areas. But those four practices, they used to be called low impact development. And their concept is that you can integrate those into the development. So let's say you're coming and you want to build a new building in India next to your river. If the city comes and says, okay, well, the parking lot of the building, you can use permeable pavement to allow that water to infiltrate through it. All the runoff that comes from the roof needs to be stored in a rainwater harvesting tank. It could be underground or above ground. The areas that are not covered by that permeable pavement, if that water is flowing out, instead of putting a small strip of landscape to make it beautiful, you can make that strip of landscape depressed. That's a rain garden. So now in one building, you have put rainwater harvesting that's capturing runoff from the roof. You've prevented the runoff from the parking lot, and any extra runoff is caught by the bioretention area or rain garden. If you have a possibility to, if there's a roof that roofs usually are big and don't go in one downspout. So if you put a rainwater harvesting from one downspout, for the other areas of the roof, you can put a green roof, which is basically potted plants lined in that area with a foot of soil. That's enough usually to capture a lot of the rainfall in it. A foot of soil can hold up to 4 or 5 inches of rainfall in it, right? Because it's a porosity, it's 40%. So
would it have any structural constraints having it on the top?
So if it's a big building, you have to get a structural engineer to analyze whether
how much
the
weight
of 1 foot of soil filled with water if the building can handle it. Now a lot of people usually they build their house so that it can retain. So if it's a small house, usually that's not likely. But for like this building we're in, it's definitely structurally able to do. All the downtown buildings, they're structurally able to do. So if you're going in your city in India, the most common type of building is a 10-floor building, 11-floor building. Those because their foundation in the bottom is made to hold 10 stories. So that an extra foot of soil is nothing. Right. But small houses like my house here, it will never hold rain. Green roof.
And so in between the green roofs, the storm retention, the permeable pavements and rainwater harvesting, do you think all these things for existing structures and for new developments also, do they have an impact on the flood peaks that you see inside an urban river?
Very good question. So we actually, the folks downstairs, that's what they're going to model for an area of Hyderabad. They want to investigate that. The reason they came to me is because we already did this for the city of Dallas. And I will send you the link to that report. Yes. It was a grant from the Nature Conservancy. And I worked with them and with the city of Dallas, and we modeled all the parts of the city where we were able to get data and analyzed the impact of putting green infrastructure. But for this project, we put it everywhere we could put it. We put one tank on every house.
Right.
Every sidewalk, we put a small rain garden.
Right.
Every parking lot, we put the bioretention area in its median. And then we ran the model. We ran it for the 2-year, 10-year, and 100-year storm now. And then we ran it also for the 2-year, 10-year, and 100-year storm, accounting for climate change in 2045.
Fantastic.
And what we found was that uh, that green infrastructure can reduce up to 35% of the flood
Peaks.
water in these storms. So
Right.
that is more than third of the of the flood water. But we also compared this to what if instead of putting green infrastructure, they would put pipes. So we found out also that the pipe system, if we want to make it bigger to account for these flooding, uh, there's a limit on the size of pipe you can use because because how the water is flowing and you can't put the pipe above the ground, right? So with the maximum size of pipe size we could put, that was able to take care of only 40% of the flood. So we recommended that a combination of those will take care of a large portion, like
Right,
70%.
75%, yes.
But we found out, that's most importantly, that the cost per gallon of water retained in green infrastructure compared to pipes and a project was 1/7 of the cost of the gallon flowing through a pipe due to replacing the pipe size. So it was way cheaper.
Wow.
So that's why so if you have money, you should put green infrastructure first, reduce that 30%, then start in those very expensive capital projects that will add the other 40%.
Right.
And then you need to look at other creative ways, detention ponds or underground large storage, to take care of the remaining 30%.
Right.
So